Sometimes on those SATs and ACTs and standardized tests, you're only going to get a bank of data. And to analyze this, you need to know what you're looking for. As you can see, the values for the x are different. The values for the y could repeat, like in this case, 2 zeros, 2 threes. The y term sometimes is referred to as f of x, but it means y. And as was pointed out before, what we're looking for is a turning point, the time where these numbers are getting progressively smaller and then all of a sudden start to get larger again. That's the parabola changing the direction, whether it be a downward or an upward swing. If we were to look at this, the place where this parabola changes is here. This is the turning point of this parabola. Also, we have the x term as being the axis of symmetry. So if we were to plot this point on our graph, 1, 2, 3, and 1, this point would be the point where the parabola turns, and the 3 would be the axis of symmetry. This point is the turning point. Now, if we were to actually go through and plot these points, which we will do in a second, you'll be able to see the actual form of the parabola. But right now, we can tell that these two pieces are our x-intercepts. This is where the parabola is going to hit the x-axis. So at 1, 2, and 0, and at 4, 0, 1, 2, 3, and 4, that's where we have our x-intercepts. On the graph, we also see our y-intercept. This is where the parabola will hit the y-axis. And we can tell from this 0, 8, and here's the zeros in the x-intercepts. So that point would be 1, 2, 3, 4, 5, 6, 7, 8, right there. That would be our y-intercept. Now the rest of the points just kind of fill in the parabola, so we'll be able to see it. -1 and 15. Here's -1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So at this point, we've got our first ordered pair. Then we've already plotted the y-intercept. Here's 1 and 3. So 1, 1, 2, 3 would be here. Here's our parabola starting to form. Here's where we have the axis of symmetry and the turning point. In this case, our turning point is the minimum. It's a minimum point because it's the lowest point that this particular parabola will go. All right, here we have our next point, 5, 3, 1, 2, 3, 4, 5, and 1, 2, 3. This point mirrors the 1, 3. And the two x-intercepts mirror each other as well. The mirror being the axis of symmetry. If we were to fold this parabola on the dotted line, these points would match up perfectly. So here we are. What's the matching point to this one and the matching point here? We can do it mathematically if we put a 6 into our x, but we also can pretty much figure that the next number on the y is going to correspond to this one, So we have 0, 0, we have 3, 3, we have 8, 8. And the 7 would correspond to a 15. So let's put in those points. 1, 2, 3, 4, 5, 6, and 8 would be about there. And then 7, 1, 2, 3, 4, 5, 6, 7, and 15 would be here. So our parabola now, we're finishing it off. And because the A term was positive, we have an upward opening parabola.